Good evening, viewers. As we discuss many issues related to the murder of Sushant Singh Rajput, our channel also tries its best to inculcate a love for everything Indian, returning to our roots and discovering our religion, our culture, traditions, our language, and our customs. The importance of being Indians and holding our heads high is very important. That's why we encourage you and more youngsters to listen and spread the message to all when we invite experts in different fields. The history of maths in India goes back over 3,000 years. The ancient Indian mathematical works were composed in the sutras in Sanskrit language in verse form to aid memorization. These were followed by prose commentary that explained the problem in more details and provided justification for the solution. All mathematical works were orally transmitted until 500 BCE, and thereafter they were transmitted both orally and in manuscript form. There are about 30 million manuscripts in India today, the largest body of handwritten material anywhere in the world. In the classical period of Indian maths, 400 BCE to 1200 CE, important contributions were made by many scholars, including Aryabhatta, Pingala, Brahmagupta, Bhaskara I, Bhaskara II, Hemachandra, Katyana, Sridhara, Virahanka, Varahamihira, Apasthama, Baudhayana, Manava, Yatiswar Sabha, Pavulur, Balana, and Panini. All quite like tongue twisters, the names. The Indian scholars made seminal contributions in developing the decimal number system, concept of zero as a number, negative numbers, arithmetic, algebra, geometry, and trigonometry. Today, we have a very special person with us from Melbourne who has spent much of his life studying maths, a subject usually people dread, but he wouldn't term himself as a mathematician. He's termed as a historian. Having initially studied economics at the University of Melbourne, Jonathan J. Crabtree is an autodidact studying the history of maths since 1983. In 1968, at the age of 7, Jonathan noticed a 398-year-old problem with his teacher's explanation of maths. India's zero was missing from England's 1570 definition of multiplication, explanation of mathematics. India's zero was missing from India's 1570 definition of multiplication. Having been perplexed by this and other maths education errors during his school years, and then at the age of 21, Jonathan found himself in a hospital facing bleak news. If he moved, he might never walk again. With both his dreams and spine shattered, he prayed for a miracle and promised to fix maths if he ever walked again. Today, elementary maths historian and Podometric founder Jonathan J. Crabtree is a guest lecturer at schools, universities, and maths conferences. Having reviewed writings in Latin, Greek, Arabic, Sanskrit, and other languages, his provocative presentations reveal how the foundations of ancient Indian maths are vastly superior to many Western ideas taught today. Welcome, Jonathan, to our program today, and we are delighted to have you with us.
Thank you very much, Meena. I am greatly honored to be with you today. And also namaskar to everyone watching on their mobile phones, on their computers, wherever they may be in India and around the world.
Yes. Yeah. So I've known Jonathan for quite some time on Twitter. We've been exchanging notes, and I found it him amazingly, interesting, and also the fact that he has a lot to contribute to India by way of Bharatiya Maths. So today, viewers, let's ask him a few questions because all of us will have some doubts about how Bharatiya Maths is different from Vedic Maths and other points. So, Jonathan, shall we go straight to the questions?
Absolutely.
Yeah. Okay. Can you give us a little bit of background about how you got involved in Indian maths and what events led you to become such an expert?
Okay. Well, there's two parts to that question because it's firstly how I became involved in mathematics, and also how I came to be involved in explaining mathematics the way that I do. So I'll take each part because they're quite different answers. And so the mathematics really was as simple, like, many crores of children around the world. I was confused by many of the things that my teacher said to me. And at one stage, my mathematics teacher said to me, "Don't worry, Jonathan, mathematics is only hard if you think about it," which is a very strange thing to say. It's almost like we're told, don't think about mathematics, just obey the teacher, just obey the laws and follow the rules. So to be an inquiring person and asking questions about why are things, there's no answer except that they're the laws. And teacher after teacher over hundreds of years and many generations have really just been repeating laws and rules rather than explaining intuitively how it worked. And as a child, I wanted to know how things worked. I liked pulling things apart as a child, and I loved playing with toys and building blocks and so on. And all young children are very interested in mathematics. They love to count. They love to build with their play blocks and so on. But what happens is we get to school and then suddenly things start to become hard work, when often up until we get taught, things come a little easier to us. So, as you said in my introduction, I didn't enjoy mathematics at school because I found it confusing, and I also never got explanations from my teachers that made simple common sense. It was not like any other subject that I learnt, which was quite obvious, but mathematics became a subject all about memorization rather than meaning and understanding. So that's one thing, and I think that I was a little bit stubborn, um, and I think that because I wanted to understand mathematics, I was a little bit slower to learn mathematics than many other people at school. I was quite a slow learner, but what I think I was a deep thinker. So if you don't have any real grasp of the roots of mathematics, you skim across it. And as soon as you leave school, or a year or two later, most of the mathematics people learn is forgotten because it's all about the rules.
Yeah.
So that's one aspect that I've wanted to find out actually how it really does work. And because I had trouble when I was 7, back in 1968, I always had the goal that I wanted to be able to explain mathematics to young children in class 1, 2, 3, and 4. Because if you can get children to really like mathematics in those first few years of school, that will last them a lifetime. But if they don't get the right explanations, it will make them feel stupid for a lifetime. And I felt from my schooling, I eventually got an A, in class 12 when I left school to go into university. I eventually got an A, but it was a big struggle. And I felt quite stupid as an adult, I've got to say, because I struggled with mathematics. And many adults are very clever, very gifted people, but they secretly don't feel as clever as others because they struggled with mathematics.
Yeah, absolutely.
And what my research has revealed is that if you struggled with mathematics, you were intuitively rejecting it. It
Yes.
was nothing to do with your brain power. It was nothing to do with your ability to learn, because so many people have had remarkably successful lives, and which requires a lot of thinking and brain power, even if they struggled with maths. So strangely, the people who struggled with mathematics were the ones who were rejecting it, and they were correct. So the people who just memorized it and did what they were told, they were trained. They were not taught, they were trained to respond to laws by memory. So I've wanted to really get to the simplest elements of mathematics that young children can understand.
Yeah.
So that's one aspect from my own childhood. Now what I'm going to do, Meena, is share with you something that I've never shared with any other interviewer, and that's to talk about my mother.
Yeah.
Now, my mother um, is still alive. She's coming up to her 93rd birthday, and she was a children's picture story writer and illustrator. So I grew up with a mother who did remarkable kind of animated designs and cartoons and stories in which the imagination was the most important thing for her.
Yeah.
So I think that one of the things that I do in my explanation of Bharatiya mathematics is I explain it through the eyes of a child with cartoons and with
That's,
games and with stories and
yeah.
with song, which is how the shlokas used to be remembered. They
Yeah.
were verses, they were poetry. And so I'm bringing back to some extent all of the fun and the whole brain thinking, the imagination, as well as the analytical side of the thinking, to just make it fun and make it really simple and intuitive. So that's really the ingredients, and it's I just became addicted to discovery, really. I just was a very curious child, and my curiosity saw me never stop wanting to know how things really worked. And I just did more research, I think, than most other people ever would have dared to.
Yeah.
So that's a bit of an answer of how my story sort of evolved and how I ended up being a different sort of teacher and lecturer is
Yeah.
from my own childhood experience and influenced very much by my wonderful, wonderful mother.
Yeah. In fact, Jonathan, see what you have said is very true, even in the Indian scheme of things in
Mhm.
schools. Because I remember I was very good at trigonometry and geometry, but very weak in arithmetic. And
Yes.
I was good, very good in other subjects, especially in English and other subjects. But I used to always feel sort of silly because I just couldn't understand maths. I mean, arithmetic, and I used to feel that I was inferior to other students. Till later in life, I realized that, just like you said, it was
Mm,
perhaps it was not taught in an interesting manner, because basically, like you would say about your mother, I'm an artist, and
mm.
I also like to explain things through diagrams and pictures, because that makes a child more interested in learning, and remembers it even more. So I think what you said is very true, and a lot of Indian mothers and children will agree with you.
Well, I think the other aspect, which I think is really important for me to say right now, is that many of the things that you were taught as a child when you were being taught about arithmetic, um, they're wrong.
Yeah.
There's no other way for me to say that. But many of the things that have been taught in the West for centuries are 100% wrong. And I I struggled for a very long time to have the confidence to start to talk about this, because who would believe one person to say that the entire history of mathematics professors and educators had gone down the wrong path? But the reality is that Western mathematics was
Yeah.
based on ancient Greek
Yeah.
foundations,
Yeah.
and the Greeks, as you know, didn't have zero, and they didn't have a concept of negative and positive. So the British, they took this system of mathematics based on Greek philosophy,
Yeah.
and they then forced it upon all of their settlements and colonies,
Yeah.
depriving local cultures of their own knowledge. And that's obviously, as you know, what happened in India twice, first with the Mughal Empire and then also with the British Raj.
Yes.
But it took me a long time also to get to where the gold was in my treasure hunt, because I started off in 1983, in March 1983, with this quest to fix mathematics. And I first started off looking at Vedic mathematics back then, and I read books by Shakuntala Devi and others. And I've bought many books on Vedic mathematics, but they still really didn't give me the intuitive explanations that I was after. It was great to learn high-speed mathematics, and it was great to give me the ability to do things faster, but I was still missing that intuitive, simple explanation that I was seeking as a child and never let go. So after that, as you said in your introduction, I started to explore mathematics in all sorts of different languages. And I'll just clarify, I don't speak the 19 languages that I've done my research from. I've always had the great kind help of Sanskritists and professors of mathematics all around the world who have helped me with translations from all sorts of languages, including Hebrew and Chinese and Dutch and Spanish and so on. So I kind of, in a way, at one stage, just before I quit my job, after I studied economics at Melbourne University, I got a job in a management consultancy firm. And when I quit my job to teach mathematics with no qualifications, just with this firm conviction that things didn't really make sense. Now, it really took probably 32 years before I really started to look into the Sanskrit. So I'd gone through the Latin, ancient Greek, Arabic, French, German, Italian, Russian, Dutch, Czech, all these other languages, looking at the writings of mathematicians in the West. But really, when I started to go into the writings of Aryabhata and Brahmagupta and Bhaskara and others, it really excited me, because it was beautiful mathematics, because it was symmetry. Symmetry was there. There are many things that we are told that are just totally wrong. And if you'll let me, I'll just give you one example. And that is the case of negative numbers. Now, when you went to school, and the people who are watching this now, you were all told that negative numbers, by definition, are less than nothing. They're less than zero. And that's a very confusing concept. How can anything be less than nothing at all? As a child, we would say that having nothing is the least amount of anything you could ever have. And that childhood intuition is correct. So numbers simply count or measure quantity. Okay, that's all numbers really do. They just count or measure quantity. And the least quantity of matter or energy, if we wanted to go into the laws of physics, the least amount of matter or energy you can have in the universe is zero. So when we are taught mathematics, it's meant to help us understand physics and engineering and everything else. But when we're told as young children that negative numbers are less than nothing, it's absurd. It confuses everyone, because it is absolutely false. If we've got one positive positron and we've got one negative electron, we bring them together, they release energy and disappear to zero. And the universe arose from zero. And there's, people who are physicists who talk about the zero-sum universe and so on. And it seems that shunya is really the heart of physics, and mathematics is the language that explains our universe. And so the Sanskrit writings of the astronomers was spot on, because the astronomers in India were scientists. They were first off, they were astronomers first and mathematicians second. And so mathematics is what they used to record their empirical observations, okay? And yet the mathematics that came to us via Britain over the last 500 years was really based on philosophy. Now, we cherish thinking, but we don't really ever assert our own truth over what has just been rammed down our throats. And I think that that's been the difficult thing for me as well, is that many of the heroes that I had were people in the West. And then we kind of find out that they didn't really always do things the first time around. And recently, over the last decade or so, we've even had a lot of research into how the origins of calculus were in Kerala and not with Leibniz and Newton.
Okay.
And yet all of the history books are always written by the victors and the powerful, and the truth is usually trampled.
Yeah.
And so I really want to just share my joy at having discovered the mathematics from the Sanskrit of India that brought me personal joy and understanding. So when I've explained mathematics to children in a way that is consistent with the Sanskrit of India, the children don't have any issue with it. They don't find it, overly interesting, but it just all makes sense. It's just totally simple. And then when you introduce it with cartoons and games and songs and colors and so on, that's when you start to have the fun factor come in, and children can learn mathematics so much quicker when you simply give them the right building blocks to play with, and then everything starts to fit together.
Yeah, very interesting, Jonathan. Can you tell me what's the difference between Bharatiya Maths and Vedic Maths?
Well, as you might imagine, the Vedic mathematics, as you mentioned, is very, very old. The Vedas were really around about 2,000 years before the golden age of Aryabhata, Bhaskara, and Brahmagupta, and so on. So if we accept, and the dating of the Vedic period is open to interpretation, and it may be a lot further back than Westerners concede, but basically the Bharatiya mathematics era is around about 2,000 years after the Vedic era. And so the mathematicians like Aryabhata and my hero, Brahmagupta, they were writing, building on their knowledge of the ancient sacred texts and the oral tradition. So to some extent, the Vedic mathematics that I started to look at back in 1983, it was about calculation. It was, there are the 16 sutras, and they're really about how to do calculations. Whereas the concepts that I didn't find in the Vedic mathematics, I didn't find the symmetry, the beauty that I was after, but I did find that in the mathematics that developed subsequently in India, especially in the writings of Brahmagupta, because Brahmagupta defined zero. He didn't just use zero like Aryabhata, he actually defined zero as the sum of equal and opposite positive and negative quantities. So there's a natural symmetry there. And then he gave us all of the sutras in his writings, in his 18th chapter on algebra, and those really have been known for a very long time in India. But what I've done is I've pulled them apart, I've simplified them, and I explain them with simple pictures and cartoons and color, so they make total sense to children. And some of the laws that were documented by Brahmagupta and others are completely the opposite of what the West has been teaching. And yet the laws or the sutras of Brahmagupta and others are the ones that make total common sense, and they're the ones that are consistent with today's laws of physics. So if we wanted children to become really experts in artificial intelligence, in quantum computing, in all of the technology-based subjects to come, which rely very often on a good understanding of physics, then we've got to give them the mathematics that's consistent with the laws of physics. And strangely, that's the mathematics that was around 1,500 years ago that the West completely stuffed up. And they weren't alone in stuffing it up. India's mathematics, or Bharat's mathematics, also failed to be understood in the Arabic world as well. So it's really just a totally amazing story that I've been able to document with all my research about how mathematics from India got lost as it traveled west. And then through invasions of the Mughals and the British influence and so on, India's own understanding of mathematics also evaporated in India. So even though I'm not a Sanskritist, I'm coming back and showing people the Sanskrit texts and explaining it, and they're suddenly realizing this is different, but this is really simple and powerful. So at the moment, everyone is awaiting the new mathematics curriculum from the Modi government. I'm hoping, my fingers are crossed, that they read the letters that I've been sending them, just saying, let's really revisit the mathematics curriculum up to at least class 5, to make it simple for India's children to really love their own culture, their own science, their own heritage.
There's an interesting question from a lady, Sharmila. How would anyone be able to apply Bharatiya Maths in daily life? Actually, in painting, we use a lot of maths or visual calculation of unconsciously, and it works. We use a lot of maths. She says subconsciously.
I think that the way to think about mathematics, in a way, is to disregard what you've been taught at school about positives and negatives. And I always like to incorporate color, and I'm actually talking about a way of thinking now as opposed to the mathematics. But what I always look at doing is I've done mathematics where I use many different colors of pencils or pens when I'm doing drawings. Very often I'll do drawings and I will then go to bed with a problem, a mathematical problem, and very often what we're thinking about before we go to bed becomes what we dream about. Now, I've also run many lectures and courses on how to think more creatively and how to use our brain better as well. And what I do is I always have a notepad near my pillow. And more recently, I've had my my phone, and I will often wake up in the middle of the night. In fact, I sleep on the floor, so I always wake up once or twice a night. And most of the time I wake up out of dreams of mathematics. Now, those dreams are your right hemisphere of your brain, your creative side, talking with your left-hand side of your brain, your analytical side.
Yeah.
And so the way that I would also suggest people contemplate problems, don't think hard, think soft. And this might be a little off topic, but one of the things that I get people to do whenever they have to think is I get them to do a visualization exercise where I get them to breathe in a white light through their nose and exhale a grey cloud, which can be negativity or ill health or whatever it is. And imagine that you're an empty vessel and that you're filling yourself up with a white light. Now, I then would snap my thumb and finger on my left hand and keep a finger and my thumb together to help me stay in a sort of a meditative state, which allows both sides of the brain better access to communicate with each other. Now, very often, people kind of know that they get great ideas if they're under the shower, for example. Many people have ideas in the shower, or they might have them on the toilet, or they might have them when they wake up in the morning. But the more that you practice a sort of a gentle approach to contemplation rather than thinking, just contemplate things, you'll often find that wisdom and insight just comes to you almost effortlessly if you just wait and let the concepts, the ideas come to you. It's almost in a way like you're tuning in a radio station and you're allowing your receiver to just receive the signal from out in the universe, and those ideas and inspirations can come. So I often say to people that I don't really feel that, I mean, I've done a lot of creative mathematics, but I can tell you that they nearly always come out of my dreams. And one of the most interesting dreams that I had back in around about 2004 was I dreamt of a goddess called Tenretni and the creation of number. And I created a video of that dream because it was a very weird dream. And so somewhere on one of my YouTube channels, I've got this really ancient old video from about 2008 or 2009 in which I tried to reproduce the dream that had come to me. But that was a dream about a goddess creating number, creating dots, and it was almost like the birth of number with the birth of the universe and the first thought. Now, this sounds very esoteric, but what you will be amazed by, and I'm sure that you probably know this anyway, but your listeners may not, and your viewers may not, and that is that your brain is a remarkable receiving device for receiving ideas. Let them come to you, and then you can start to drop the struggle, and you'll find yourself leading a more intuitive, creative life, a more balanced way of thinking. So, you know, there's no simple answer. There's no simple magic trick that I've got that suddenly makes you a genius mathematician. But all the ideas that I share with children are really aimed at integrating both sides of the brain. So the left and the right side of the brain are working together in the classroom. That aids the insight and the understanding, and then the child's ready for the next ideas. And also, the child will also have the creativity and the confidence to come up with his or her own ideas and solutions to problems. There's always one way that we're told to solve a problem at school, but in reality, there might be 5 or 6. And many of the ideas that we have as children might be better than the ideas that our teachers have, because our teachers have only been taught the way their teachers were taught before them. And creativity in mathematics is largely frowned upon, especially in the Western world.
Ned asks you, have you ever approached Modi government regarding teaching of Bharatiya Maths in school?
Look, I have written letters to Prime Minister Narendra Modi. I flew over to New Delhi in December last year and gave a lecture at INTAC for the Srijan Foundation, and that was really my plea to Narendra Modi to pause and bring back India's culture into its elementary mathematics education. I don't know if Narendra Modi has ever seen that video, but if you Google the death of arithmetic on YouTube, the death of arithmetic talks about how India's ideas were lost as they went through the Arabic world. And look, I've written letters, and recently I've had one encouraging email from a very senior member of the BJP who says that he's referred my research on to others for investigation. So, you know, I'm starting to be noticed, but I'm also very aware that time is running out because the next mathematics curriculum is meant to be in place by March 2021. And so I've been offering my services free of charge to NSERT and to the Ministry of Education, as you probably know from my tweets. But as yet, I'm not really sure if they've been getting through to the people in power. It would be a bit of a shame if there's a new mathematics curriculum launched next year by Dr. Nishank and others at NSERT, when I'm going to be launching a genuine Indian mathematics curriculum also at the same time. And I can tell you that when I've been teaching children and I've been visiting schools all over India, the children, I say to them that the mathematics that I am going to be showing you in this lecture is going to be different to the mathematics that you've been taught, because the mathematics that you've been taught has been created by the British. And the mathematics that I'm going to share with you was created by India. Now, at the end of my lecture, what I usually then do is I then just ask the children, which mathematics do you like more? And it's like everyone's screaming India, India, India. They love the Indian mathematics because it makes sense of everything. Everything becomes really simple. So if it's like we in the World Cup, I'm an Australian, but I'm also very fond of India. In my profile, you see I wear an Indian cricket cap. We don't barrack for the English cricket team, and yet we barrack for the English mathematicians. That doesn't make any sense. Now, Australia doesn't have any great mathematicians, but India does. Now, wouldn't it be wonderful if India's children could follow the heroes, like they know about, Virat Kohli and Tendulkar and so on, but you've got heroes there that would be able to motivate your children, and then they'll start to really want to win the war of mathematics when it comes to getting the best jobs in the world and leading the world based on their superior performance. They won't have to go to Princeton and Harvard or Oxford or Cambridge to get the best education. If India just taught its own its own true science in its own schools, people would start going to India to be taught the best mathematics.
Yeah, I hope the authorities are listening to you. I'm sure they will, because this will be available for all of them. And I'm sure now we are in the December almost. I hope they quickly think of what you're saying and take it into account.
Well, all I can do is again just say I am dedicating my life to this project. I am willing to work full-time not for pay, not for money, not for fame. Just let me give my research to the people that are going to develop your mathematics curriculum. I don't care what you call it. Just make sure that you teach the correct ideas that agree with the laws of physics. And guess what? You can start to teach children in class 1 how positives and negatives work. And by class 3, you'll have little children explaining why negative into negative is positive in a way that is correct mathematically, logically, physically, and intuitively. And they will never be confused about why negative into negative is positive. And yet the only way that we get taught that is by, it's a law of sine. No, it's not. It's a consequence of Brahmagupta, and it's how things work. So, look, India's performance internationally has been very, very poor. In the last international test, back in 2009, 2010, India ranked second last in the world, ahead of only Kyrgyzstan. Now, that is a crime. That is totally a crime. It's child abuse. And Narendra Modi, if you do watch this, and if you do nothing about the mathematical child abuse that's going on in Indian schools right now, where they're learning broken British mathematics rather than the genius of Aryabhata and Brahmagupta and Bhaskara, well, shame on you, Mr. Modi, because you promised to bring back a revival of Indic education. And whether it's through me or someone else, you must make sure that the mathematics taught to children, especially up to class 5 and 6, has the correct foundations. And they're Bharat's foundation. Not Greek, not Arabic, not British, not European. It's from ancient Bharat that you've got to start reteaching mathematics. And also next year is going to be the year after COVID. More than ever, children are going to be struggling at school. They need to get the absolute best help for them to understand mathematics. And mathematics, as you know, Meena, is so important for science, for technology, for engineering, and in the rest of the world, also for medicine, but also for many creative things as well. Mathematics is incredibly important. And so, look, let's not blow it. We've got the opportunity to revolutionize education because coronavirus has forced humongous change, huge change around the world. And look, I could go to America and New York, and I could do all sorts of fancy things over there. And I recently gave a lecture to teachers in New York State. But look, this is India's mathematics. It's not America's, it's not China's, it's India's mathematics. And I found it, I've improved upon it, but it's actually your own culture. And so it would be wrong for me to take it away and make money in the West. But I'm doing everything I can just to give this precious gift to India. And you can sense my frustration coming through. But look, I've been researching this for 37 years, and I will be creating a series of mathematics books for India's children. And there could be a mad, crazy situation where in 1 year's time or 2 years' time, there's a whole new range of maths books in India's schools, and yet all the parents are downloading the Bharatiya Mathematics books free, off the internet, and learning the maths the correct way. And I can tell you that when children are faced with a choice of what they want to learn, the old way of learning mathematics based on ancient Greek ideas, which were 1,000 years out of date by the time Brahmagupta wrote his shlokas. So it's just absurd that we keep on doing something which doesn't work. America is struggling with its mathematics education. Britain is struggling with its mathematics education. And guess what? They're starting to look to countries like China to help them out. And, we really need to strike now and reassert India as the world's Vishwaguru again. And if
which is
Narendra Modi
yeah,
doesn't
which
do
is
it, who will?
which is what Narendra Modi is trying to do. So it's important that they listen to you. Yeah.
Well,
Uh,
hopefully, either you or one of your viewers will connect somehow.
Absolutely.
And look, I've got all of my information I make available for free. I'm not selling anything. If people go to my website, which I hope you'll mention at the end of this talk, it's really too important to be focused on money. This is about fixing a cultural theft. This is about fixing history and restoring the pride back in India's children, so they suddenly realize how great their past, their ancestors were, but how great their opportunities are in front of them. So, we've really got to do something over the next few
In fact,
months
yeah.
to lock this in.
Yeah. In fact, Jonathan, see, we are struggling not only with this, what you mentioned, but also the fact that, see, our history has been completely distorted by a government that was there before Narendra Modi. And what they did was they glorified the Mughal emperors who were barbaric, and they never sort of explained the kind of kings we had who were so generous in sharing their knowledge. They were patrons of the arts, the culture, but our children never got to learn about them because everything was so distorted in their textbooks. And we've been behind the Modi government to please change it. So they've been, working on it. So we are hoping for at least a change in that. So it's very important that they also listen to what you're saying and try to implement that as well. A question here, Jonathan, is that some children have problem with numbers, autistic in nature. Will Bharatiya Maths help?
Yes, and look, I see that the questioner used the phrase Vedic. I do want to remind people that Vedic mathematics and Bharatiya mathematics are two totally different things. The Bharatiya mathematics is all about the foundation, the simple ideas which explain all of the mathematics that emerges from zero. So in Vedic mathematics, we still go on to say that negatives are less than zero. But that's not how physics works, and that's not what the Indians arrived at 2,000 years after the Vedic era finished. So really, the important thing is, I think, to use the right side of the brain. So we want to introduce rhythm, we want to introduce color, we want to introduce rhyme, and we want to introduce movement, and maybe even dance as well, which you might be interested in. And then children will just learn because it's a game and because it's fun. So, for example, if for example we've got a situation where we've got to teach a child the idea of 2 minus 5, well, that's a very confusing concept if you do it through the Western way, because and you'll not start teaching that for 5 or 6 years after a child started to learn how to count. But imagine if we had a child with a bucket and spade, and we played a game of the happy Harappan builder who creates bricks. So how do you create a brick? Well, in the Indus Valley civilization, which was remarkable for its constructions and its designs of its cities, just imagine that you dig a hole in the ground, you fill up a bucket, leave the bucket in the sun, turn the bucket upside down, and you've made a brick. Okay, so it's very simple, that idea, and a child can easily imagine digging a hole, filling up a bucket to make a brick. So if you're a brick seller and you've got 2 bricks, but somebody wants to buy 5 bricks, what are you going to do? Guess what? The children pretty soon will know they've got to make 3 more bricks. Okay, it's very simple. And guess what? How do they make 3 bricks? They dig 3 holes.
Yeah.
So if you've got 2 bricks and you've got to sell 5 bricks,
Yeah.
well, that's very simple. You dig 3 holes and you make 3 more bricks. And guess what? Then the 5 bricks are taken away, and guess what's left? 3 holes. And so you've got the idea of simple games from class 1 that children can understand,
Yeah.
and bricks can become positives and the holes can become negatives.
Yeah.
And so 2 minus 5 will, that'll in their head leave them 3 holes.
Yeah, it's
And
easier.
that's consistent with concepts of physics. So that's straight away so much fun.
Yeah.
You can have, like, kids will want to start to do that with buckets and spades and digging and having all that fun. You'll have to say, okay, enough of the mathematics. It's time to do some other subject.
Yeah. Yeah. Jonathan, the next question. If you had one secret to give about Bharatiya Maths, what would it be?
I think that the secret is really about simple common sense.
Yeah.
That's something that hasn't really figured in how we explain how things work.
Yeah.
And it kind of went off the rails because we had to follow the Greeks, because the Greeks had the concept of proof. But the Indians, they came up with their mathematics based on what they saw.
Yeah.
So Indian ideas of mathematics were empirical. They were based on observation. Okay.
Yeah.
So the West goes into so much philosophy about whether numbers are transcendental. Well, who cares if a number is transcendental or not? Let me tell you that the ancient Greeks said it was impossible to square a circle. It couldn't be done. They tried, and the Greeks were great at philosophy. And the West eventually proved it's impossible to square a circle with a compass and a straight edge.
Yeah.
But guess what? If you used rope, like
Yeah.
the ancient Indians used to use, it's very simple to square a circle. And the West never uses rope in their lessons about geometry.
Yeah.
And yet India did. And guess what? With a compass and a straight edge and your little geometry kit that you've got in school, you can't draw an ellipse.
Yeah.
But guess what? With a loop of rope, you can draw an ellipse as well. And so when we actually think about it, even the Shilpa Sutras from like 800 BCE, they had the correct concepts about how to solve mathematical problems. They had the right tools. But the Greeks said, let's not use a compass. Let's not use rope. You have to use a compass. And so we got sidetracked for over 2,000 years, like 2,500 years, just because some dumb rule that the Greeks came up with about how to square a circle. And so much was lost because India started to agree with what everybody else was saying. For some reason, India doesn't have aggressive confidence. You're too pacifistic. Like maybe if you invaded a few countries, you'd get a little bit more aggressive and defend your intellectual knowledge. But look, the Indians, their use of zero, for example, was not for designing cannons or military. It was about flower arrangements. So there was a beauty and a peacefulness and a tranquility of Indian mathematics that meant that invaders could just come along and rape your culture. And the British really, they destroyed cultures the world over, not just in India. And in Australia, where I am, our Indigenous people, the First Nation people, they had concepts of mathematics, believe it or not. And our Indigenous Aborigines, they navigated Australia, a huge, huge continent, by the start as well. And there are some ideas that the Australian Indigenous First Nation people did, which were remarkable. And yet that all gets ignored and lost. So I'm not an advocate for everyone learning Australia's mathematics, but I am actually saying that really the world, if India doesn't take up Bharatiya mathematics, guess what? The world will, because it's a better mousetrap. And the saying is, if you build a better mousetrap, the world will beat a path to your door. I'm giving all this information to India. It's in the public domain. So it makes sense for India to grab it and run with it and claim it and teach it, and then the children will benefit from it.
Yeah. Jonathan, another thing is that in India, abacus is very popular. And I hear a lot of young children saying that, see, it makes maths much more easier. What are your thoughts about that?
Look, the abacus is great for calculation again. And you can train yourself to do remarkable things with an abacus in the mind, where you don't even have a physical abacus. And that might be what you're referring to when they're abacus champions, where they're doing calculation in their mind with a mental abacus, not a real one. Look, I think that whatever gives a child confidence is to be pursued if the child wants to pursue it. I'm not a great fan of parents forcing things upon their children, but also I'd also say that it's possibly worth exploring the ideas of different colours with an abacus, where you might have black beads for negative and red beads for positive, and guess what? Then they can start to cancel each other out. So, look, anything that gives a child confidence is worth doing, and children love to perform. My middle son, I've got 3 boys. My middle son, I used to teach him how to do magic tricks with mathematics. And when he was in class 5, he would do mathematics tricks for the teachers. And those tricks that I taught him, the magic, they gave him the confidence to then go on and top his secondary school. He went on and did a master's degree in electrical engineering. And his little brother, who I also shared some fun ideas with, he's just about to finish a PhD in quantum computing. And my first son, he ended up doing postgraduate studies in accounting. So as it happens, all 3 of my sons have been working with numbers, and I think that they've all done very well in their careers because they didn't have any fear of mathematics. And I think that that's really the task of the teacher, is not to introduce fear of mathematics into the child, because children go into school with no fear of mathematics. I've never heard of a child that's having fun playing with blocks and learning how to count, fearing mathematics. All of the fear starts to come in when the explanations start to be wrong. And the child will feel that he or she is stupid because she doesn't understand the maths. But in reality, the child is correct. What the teacher is saying is very often completely wrong. And Brahmagupta's writings reveal how, as do modern concepts of the laws of physics, which are also completely different to what we're taught about maths via the British. So, look, really, the abacus idea, I would pursue it if the child is having fun with it. And I used to do things through creative visualization myself. And I used to teach my youngest son how to multiply 2 5-digit numbers together in his head and get the right answer with no workings, just write down the answer. And he did that for fun. And when I was a younger man, I wanted to be the fastest mathematician in the world. And for that, I would multiply 2 10-digit numbers together in my head to get a 20-digit product. Now, I couldn't be the fastest in the world. I was about 20 seconds too slow. that was a lot of fun. It was pretty useless. I mean, it was never going to help me in any way except to be a trick to show off. But um, I think that the ideas that I got with the ideas of Bharat's mathematics, they're not tricks. They're actually really simple, deep, powerful explanations of how mathematics works.
Yeah. Jonathan, let me tell you about an incident that happened in school when I was in school in 10th standard. That's the time when children are, segregated into science and arts fields.
Yeah.
Okay, and
Hmm.
it's like a public. They take you to a hall, an auditorium, and they divide the children into different two different sections. So,
Hmm.
because I didn't do well in arithmetic, I was put into arts, and every child who was moved into the arts section felt they were inferior because they did not do well in maths, and so their brains are less functional, and that they are inferior beings. So I remember that scene was always like a nightmare, because it meant that I was in some sense useless, and this would have happened to many children. It's been going on for ages. So it's very important what you say about the confidence that maths can give you when it's taught in a different manner. And if it's taught in a manner that's easily, it can be grasped easily, that becomes much more interesting for a child. And it's high time that India changed their system and listen to more experts like you.
Hmm.
Yeah. And
Thank
one
you.
more, yeah. And one, a lady says that, see, one second. So interesting. Amrita Shirali says, so interesting. Please let me know how Mr. Crabtree can be reached so schools can contact him. The kids will love it. I think towards the end, you will tell us how they can reach you.
Yes, absolutely. And look, I'm not able to visit India at the moment,
Mm,
obviously,
mm.
due
Yeah,
to coronavirus. In
yeah,
fact, I was scheduled to be on my fourth tour of India,
yeah,
but India then closed travel from international visitors 2 days before I was about to fly into New Delhi.
yeah,
And so I nearly got trapped in New Delhi with
yeah,
no hope of getting back to Australia. But look, as soon as the coronavirus situation um, is
yeah,
resolved and India has its vaccines developed and so on, one of my goals is to spend a lot of time in India,
yeah,
perhaps not teaching individual schools anymore, but
yeah,
what I want to do is I want to go to venues where I can teach hundreds of teachers short courses, maybe over 1 or 2 weeks, that allows them to go back to their own school to teach Bharatiya mathematics, which I call podometic. So
automatic.
you were talking about your struggles with arithmetic.
Yeah,
Well,
yeah,
the new name of the mathematics that I've given it is called podometic,
yeah,
and that's the website podometic.in, and
yeah,
that website is hosted in Pune, in India. So I'm also hosting the website in India to
yeah.
convey the knowledge of India as well. So look, I will also be possibly doing some online
Yes,
lectures as well.
that's what
Um,
this lady has asked.
yes,
Sir, please take some online sessions here.
yeah. So look, I have a YouTube channel which is simply youtube.com/podometic. If you go to my Twitter account, I am J Crabtree on Twitter. And if you're watching this, it's quite possible that you click the link from Twitter to get to YouTube. Um, but if you go to my Twitter account at J Crabtree, the link to my YouTube channel is in my profile. I do have many videos on my website, podometic.in. And to help it for children to remember, I've also got it as PODO, just simply podo.in. So students can find it a little quicker to get to the website, just podo.in. On that website, I've also got all of my PowerPoint presentations. So it's quite rare for a mathematics lecturer to give all the videos of their lectures and to give all of the PowerPoint slideshows as well. So the goal for me is that everybody finds this information easy to access, easy to share, easy to download, and I'm wanting to really do something that echoes for eternity. I mean, it sounds quite flowery to say that, but really the Bharatiya mathematics really should see the world through for at least another 1,000 years. We had a concept of Roman numerals for a very long time. We had in the West. We had the ideas of the British, but really the next millennia really should be about India's mathematics ruling the world once again. So for me, it's not about selling this information. That would be wrong. It's not mine to sell. It's India's mathematics. But please do go to that website, watch some of the videos, follow me on Twitter. I tweet quite a bit, and I also share a lot of mathematics through my Twitter account, more so than my website. So if you look through my previous tweets from Twitter, you'll find lots and lots of very simple ideas via my tweets, and also lots of short videos and images as well. So look, this is really the start of a journey, and for all those people wanting to join the cause, the project, you are actually the solution. It's not just me. This is about each one of you watching this video right now, taking what you've learnt with Meena and myself, and you become a messenger for India's superior mathematics. And look, one of my goals is that I want the mathematics to also be available in all 22 official languages of India. And if you search for Podometic free gifts, you'll see some resources that you can download free of charge that I could easily sell for quite a bit of money. So there's games to come, there's games to play, there's lots of fun videos, and cartoon storybooks are going to be coming along as well, all for free. So really, my most important task is just to get the notice of the Indian government and the Ministry of Education, just so we don't miss the opportunity. Because I don't want to become another Byju's and just make billions of dollars online. That's not the point. The point is to get this mathematics into every school in India. And the only way that can happen, and the only way that should happen, is through the BJP supporting the first word of the name of its political party, the B. It's about your mathematics, Mr. Modi. So this is, your chance, Mr. Modi, and everyone else watching this, to leave a lasting legacy. I've had health scares this year, as many people have, and I won't be around forever. But I certainly hope that the mathematics of Aryabhata and Brahmagupta and Bhaskara 1 and 2 and others really gets the attention and the recognition that those rishis and gurus deserve.
Thank you, Jonathan. In our own way, we'll also copy this link to some of the important people in BJP, and let's make sure that it's it comes across. Thank you so much, Jonathan. A very interesting session, and our viewers are very happy that you took some questions as well. And they will all reach out. I'll also put the details of your Twitter link in the details as well, so that anybody who wants to reach out to you can easily do so.
Yes. And if you're not on Twitter, you can also email me at info at podo.in. That's simply info@podo.in. That's my direct email address. I read every email I receive. I can't guarantee to reply to every email because I get a lot of them, as you can imagine. But they're certainly very important, and I love hearing the stories of the reactions of the children as well. So look, let's let the fun and games begin.
Thank you, Jonathan. Yeah, and good night for you, because I'm sure it must be around 12 o'clock for you there, 12:30.
Yes, yes, it's my bedtime in about 2 hours.
So good night to you.
Okay,
Thank you.
thank you very much for your time.